In this lesson, we'll be looking at the volumes of pyramids and cones. Now notice that any pyramid or cone is going to fit inside of a prism with the same height. And it has to be smaller than if it's sharing the same base, it's going to be smaller. And an interesting property of that is if you take some cones, so maybe you fill them with sand or something, and you pour them into a prism with the same base, same height, then it's going to fill it exactly three cones or three pyramids is going to fill the solid. And so the formula for this is going to be 1/3 of the area of the base times the height. That's going to be the same for the volume of a pyramid or a cone, although for a cone we can use pi r squared for our base, but it's still the same formula. Okay, so one example here, we have this pyramid that's a stadium in Memphis, Tennessee, and the base is 600 feet wide. That means we have dimensions of 600 and 600. It's about 350 feet tall, which would mean we're looking at the altitude here coming down the middle, and so that would simply be our height. So our volume being base times height, our base is that square there, so 600 times 600, or 600 squared, and then times the height, so 600 squared times 350 is going to give us 42 million cubic feet. Next example, we're looking at the volume of the cone. Notice what they give you on this one. We have a 48-degree angle here, and we're given the height. And what we're going to need to find the area of the base here is the radius, because we need pi r squared. So we're going to have to do that this time using trigonometry. So I have 48 there, which means we're going to use the tangent, which is 10 over r. So r will be 10 over the tangent of 48. Which rounds to about 9.0, or just 9. Our volume then would be, again, 1/3 of the base times the height. So we'll use, for our base, pi r squared times the height, which is 10. And that's going to come to about 848.2 inches cubed. The next example will be using Cavalari's principle. Remember, this was again when we push something a little bit off center, and we'll still be using the height, which has to be perpendicular to the base, times the base. So this works not only for prisms but also for cones and pyramids. So if we want to find the volume of this, we're still going to use our formula. Volume is 1/3 of the base times the height. Our base here is still a circle, so it's still going to be pi r squared. And our height, since we're looking where it's perpendicular here, we're going to the vertex down here, so the height is 12. Plugging those values in, we're going to have 1/3. This will work out to 73.96 pi times 12, which comes to about 929.4, and our units would be inches cubed. The next section is about surface areas and volumes of spheres. So we're just going to simply look at the formulas here. Mostly all you need to know about is the radius to be able to use either one of these formulas. The 4 pi r squared is actually kind of interesting to see. If you look at something like a baseball, if you unfold it, you'll notice that the shape is made of 4 circles being put together. These circles aren't exactly the same radius as the baseball, but we see the basic idea of how 4 circles can come together to make a sphere. Now also with the sphere we have a little bit of vocabulary. They might talk about a great circle. This will be the biggest circle that we can get. So it's going to be cutting a sphere in half. It's going to pass through the center of our sphere. The circumference of a sphere then would be the biggest circumference that you can get, which will come from the great circle. So that circumference would also be the circumference that uses the radius of the sphere. We can also talk about a sphere being cut in half, and so it would use the great circle as the side of that hemisphere. Okay, if we want to find volume and surface area then, the most important thing again was radius. Now notice they don't give us the radius in here, they give us the circumference, so I'm going to have to find that. If our circumference is 36, I'm going to think about my formula, circumference is 2 pi r, and use that 36 to solve this for r. So my radius will be 36 divided by 2 pi. Looking at my volume then, 4/3 pi r cubed, I could plug in my 36 over 2 pi. My surface area, I would just do the same thing. 4 pi r squared, but I plug in 36 over 2 pi. This one will come to about 787.9 centimeters cubed. And our surface area come to about 412.5 centimeters squared. Okay, now we're looking at a hemisphere, and it's going to be half of the volume. So starting off, our volume is going to be just our 4/3 pi r cubed, but then we divide everything by 2. The surface area is going to be a little bit more complicated than that. Notice with our surface area, I'm going to start by taking my 4 pi r squared, that's my formula, but it's cut in half. But then notice that there's another new surface on the outside of this, and that's the great circle. It's going to be using the same radius, so I have to add that circle there. It's kind of like adding a base to this, pi r squared. If I simplify this formula, this part will give me 2 pi r squared, plus, again, that great circle there, pi r squared, will give us 3 pi r squared. So if I plug in the radius for these, looking back at my picture, that radius, since they gave us the diameter, the radius would be 2. And that would give us 16.8 cubic feet for the volume. And for our surface area, it will give us 12 pi, or about 37.7 square feet.